Okay. So today we will discuss capacity of driven pile foundation. Okay, uh, so last meeting we discussed yung introduction to pile foundation. So we determine the different types of piles based on material use, based on the load assumption, and based on the uh, uh, method of construction. Okay, so we will focus on the capacity of a driven pile foundation or yung displacement piles. Okay, so for the capacity of driven piles or the deep foundations, we have two considerations. Number one is the pile in a sand layer. Okay, and number two, we have the pile in a clay layer. Okay. Uh, If you recall dun sa last meeting on Module 18, the forces acting on the pile foundations are the the end bearing, okay, yung ang tinatawag nila na Q-tip or the contact area or the contact force and the skin friction. Okay. So that is why dito mapapansin nyo meron siyang Q sub F and Q-tip. Okay. Yung Q is the actual or the demand force na kinikerry ng ating piles. Okay? So ito yung Q na kinikerry ng ating pile. Then yung Q sub F is the skin friction, the total skin friction. And Q sub tip is yung end bearing force ng pile. Okay. So the formula for the skin friction in a of the pile in a sand layer is given by P times A times K times mu. Okay. So ang nangyayari kasi class sa buong perimeter ng pile. Okay. So for example, ito yung piles. Ito yung piles. Sa buong perimeter ng piles, magkakaroon ng skin friction diyan. Okay? So, meron yung skin friction dito, okay, all throughout its perimeter. And paano ba kukunin yung force dun sa skin friction, dun sa from P6, 'di ba? Ang force ng friction is due to normal force times the coefficient of friction. That's why meron tayong normal force. Okay, so saan ba ito? Ito yung normal force. Normal force, okay, this is due to normal force, yung A times K. Okay. Coefficient. Okay, sorry. Ito yung normal force, yung area of the pressure diagram. Okay. Then yung K is to convert the normal force to lateral force. That is why meron kang coefficient of lateral pressure. Okay. Then a factor ng perimeter of the pile para to sum up all the forces in the perimeter of the pile and yung coefficient of friction. Okay? So kaya ganito yung formula natin ng P times A times mu, or naalala ko nung nagre-review kami nung board exam, ang ano namin dyan is PAC mu. Okay? PAC mu. Yan yung memorization namin for the skin friction sa piles in a sand layer. Okay. Then for the Q-tip, okay, or the bearing, the end bearing force, okay, end bearing capacity for the piles in a sand layer is given by P sub E NQ times A tip. Okay. So P sub E is the effective pressure at the bottom. Okay. So it is buoyant, yung effective pressure dun sa pinaka-bottom ng pile. Then NQ is the soil bearing factor. If you recall yung NQ, dun sa analysis of shallow foundations, yung NQ, yung soil bearing factors. Okay, and A tip is the area of the tip or yung contact area sa piles nyo. Then the total capacity Q sub T is given by the sum of skin friction and the end bearing force or end bearing capacity. Okay. And your designing capacity is given by the total capacity Q sub T by divided by a factor of safety. Okay. So yan yung piles in sand layer. So the question is, ano yung pressure diagram? Okay, di ba? Puro may pressure diagram dito, yung A. So ito, ano yung pressure diagram na yun? Ang pressure diagram natin is just like this one. Ito. So ang pressure diagram for piles in a sand layer is given by this one. Okay. So ang mangyayari, class, up to a critical depth, D sub C, linear or linearly increasing yung pressure. Okay, ganyan yung sa sand. And up to that point, nung critical depth, D sub C, is uniform na yung pressure diagram. Okay? So, ano yung critical depth D sub C? So, for a loose sand, okay, ang critical depth is 10 times the size of the pile or 10 times D, diameter of the pile. For dense piles, for piles in a dense sand, that is 20 times the size of the pile. Okay? So yan yung piles in a sand layer. So ibig sabihin doon sa piles in a sand layer, again, linearly increasing yung pressure from the tip hanggang doon sa critical depth D sub C, and after that uniform na yung pressure niya. Okay? So ito yung pressure diagram na tinutukoy dito sa letter A, the area of the pressure diagram. Okay. So next, we have a piles in a clay layer. Okay. So for the skin friction in a piles, for a pile in a clay layer, we have three methods. Number one is yung alpha method na tinatawag. Okay. Number two is yung beta method, and number three is yung gamma method. Okay. Ang tanging nagbago lang dito sa mga to ay yung frictional factor. Okay. Sige, tingnan natin yung mga factors na yan. So, unahin natin tong pile in a clay layer given alpha method for skin friction. Okay. So, for a pile in a clay layer using alpha method, your skin friction is equivalent to clap or yung C times L times alpha times P. Whereas yung CMO is the cohesion of the clay layer. Okay, L is the total length of the pile. Alpha is the frictional factor, and P is the perimeter of the pile. Okay, so ang nangyayari rin dito is the total length of the pile times perimeter, or meaning the surface area of the pile, multiply siya sa cohesion and the frictional factor. Okay? Again, the total surface area. So surface area kasi yung perimeter of the pile times the length. Okay? So total surface area of the pile multiplied by the cohesion and the frictional factor. Okay? Then for the Q-tip or the Q bearing or the bearing capacity and bearing capacity is given by CNC A tip. Okay. Kung mapapansin nyo, ang soil bearing factor dito is yung N sub C. Kasi nga may cohesion ang mga clay layer, ang mga clay soil. So the formula is letter C, that is cohesion. NC is the soil bearing factor given by dun sa Terzaghi equation or the modified Terzaghi equation. A tip is the area of the tip. Okay, it's almost the same dun sa ating piles in a sand layer. Okay, then the total force or the total capacity is given by the sum of the skin friction and the end bearing capacity or the Q sub tip. And for the design, okay, syempre for the design, we don't want to design our structure na ibig sabihin yung sagad or naka maximum. Okay, kailangan meron tayong allowance or factor of safety na included dun sa design natin. So to compromise yung mga some errors in the construction. Okay? So mga unknown errors yan, pwede yan. So yan, so therefore yung Q designing mo is the total capacity divided by a factor of safety. Okay. So the other method for the skin friction is the beta method. Okay. So as you can see, for the beta method and the clap method and the clay layer and the alpha method. So meron din siyang L times P or the total surface area. So i-rearrange ko lang to. C times alpha times L times P, which is this one is the surface area. So just like the alpha method, so beta method, meron din tayong surface area times the force FAB. Okay, dito kasi yung FAB nito is C times alpha. But this one, yung FAB nito is different. Okay, ang formula dito is 1 minus sine phi tangent phi sub r, okay, multiplied by the sigma average. Okay, whereas this one is your beta. Ito lahat yung inyong beta factor. And ito yung force. Okay. So, parang ganito siya eh. Parang ganito rin. Ito yung alpha factor and ito yung force or yung stress. Okay, katulad din dito. Ito yung beta factor, ito yung stress. Okay. So that is why yung beta factor nyo is 1 minus sine phi tangent phi sub r. So the question is, what are phi sub r, sigma average, and phi? Okay. So in our equation, P times L is the same, which is the perimeter of the piles and the length of the piles. So what is phi? Phi is the internal angle or yung angle friction. Okay. Phi sub r is new notation that is equivalent to the shaft soil friction angle. So ito yung the friction angle between the interaction of the shaft and the soil, or siya yung tinatawag na shaft soil friction angle. And sigma average is the average pressure per soil layer. Okay, take note, sigma average is the average pressure per soil layer. Okay, so more on this kapag nagkaroon tayo ng example problem. Okay. So next method and the last method is for skin friction is the gamma method. Okay, for the gamma method, it's basically P times L again times FAB. Okay, whereas your FAB is given by the gamma factor multiplied by phi sub V plus 2C. Okay, so in gamma factor, the sum of the total, your phi sub B is the sum of the total horizontal force exerted in the piles divided by the total length of piles. Okay, so parang ang nangyayari, meron kang, yung phi sub B is the horizontal force per linear meter of piles. Yan yung other notation for phi sub B. Okay, that is total horizontal force per linear meter of the piles. Okay, so parang ito siya. Ito yung pile mo, meron niyang per linear meter na force. Okay. Then after that, kung mapapansin nyo, meron siyang time plus 2C for the cohesion value. Then the omega, the gamma factor. Okay. So yan yung gamma method. Okay. Whereas yung P natin is again the perimeter of the piles, L is the length of the pile, and C is different this time. That is the average cohesion of the soil. Okay. Kaya siya capital C, average cohesion of the soil. So that is the how you solve for skin friction for using the gamma method. Okay. So the question is, kailan gagamit ng alpha method, beta method, and gamma method? They are all pwede silang gamitin lahat. Okay. Depende na lang kung ano yung given sa problem na ng mga factors. Kung meron ka alpha na given, so you will use alpha method. Pero kung may given ka na let's say sigma r and P average or the average pressure per soil layer, you can use this beta method. And for gamma method, given yung gamma value, and you will use gamma method. Okay? So itong mga to is pinopose lang to estimate the total frictional force or acting on the piles. Okay? So yan. Okay. So for the driven piles in a clay layer, so let us try to solve for example problems. Okay, yung driven piles in a clay layer. Ayan. So it is a past board exam in May 2005. Okay. 0.36 meter square pre-stress concrete is to be driven in a clay soil as shown in the figure. So the capacity of the pile is 360 kilonewton with a factor of safety of 2. Okay, sorry, the design capacity of the pile is 360 kilonewton with a factor of safety of 2. So the question is, compute the end bearing capacity of the pile, compute the skin friction expected to develop along the shaft of the pile, and compute the length of the pile if using alpha method where alpha is equals to 0.76. So therefore ang unknown pala dito is the total length L. Yan yung unknown dito. Kasi meron tayong designing force 360. Yung 360 na yan, may factor of safety na ito na. Okay? Then ang given, as you can see, yung given din dito sa ating figure, meron tayong unconfined compressive stress, Q sub U, which is equals to 110 kilonewton per square meter. If you recall, yung unconfined compressive stress, okay, ang for the shear strength of the soil, di ba? Ang Mohr circle nun is this one. Di ba? Okay. Whereas, dapat dito, I think dito. Yan. Yan yung Mohr circle na. So, ito yung Q sub U mo. Okay? Then, ang unknown is this value. Okay? So, yan yung kailangan mong hanapin yung for the cohesion, di ba? So, ito yung cohesion, di ba? Cohesion and this one, okay? Or yung tau sub F or the shear strength. Okay. So, as we all know, di ba, kung yung C na to, kung ito ay diameter of the Mohr circle, so this is the radius. So, therefore, your C is equals to QU over 2, di ba? So, yan yung gagamitin natin to determine yung cohesion value. And the unit weight of the soil is 18.1 kilonewton per cubic meter. And given na yung bearing factor, soil bearing factor na N sub C, which is 9. Okay, so let us solve for the total length L. Okay, so number 1, compute the end bearing capacity of the pile. So for unconfined compression test, you can recall yung module natin for the shear strength of the soil. So the cohesion is QU over 2, that is equal to 55 kilonewton per square meter. Okay. So what is the formula for the end bearing capacity of the pile? That is C times NC times A tip. Okay, so sasauluhin nyo lang. So that is 55 times 9 times 0.36 times area 0.36. This is yung area of the tip. NC is 9, C is 55. So therefore, your Q sub tip is 64.15 kilonewtons. Okay. Next, the question is, compute the skin friction expected to develop along the shaft of the file. So, dapat ito yung alpha na nasa number 2 di ba? So, anyway. Hindi pala. Force pala hinahanap for number 2. Okay, so kung yung Q-tip natin is 64.15 and yung ultimate capacity natin is unknown. Okay, so ang gagawin mo, di ba yung Q-des is equals to Q-ultimate over Fs. So to determine yung Q-ultimate without a factor of safety, That is 360 times 2. Therefore, your Q ultimate is 720 kilonewton. So therefore, the only remaining value is if you see friction is 720 minus 64.15. Okay. So 720 minus 64.15, that is 655.85 kilonewton. So this will be your answer for the remaining skin friction force. Okay. Next natin is the total length of the pile. So very straightforward question lang. So meron ka ng total friction, total skin friction using alpha method, that is 0.76 times 55 times 0.36 times 4. This is your perimeter of the pile. Okay. 0.36 times 4, that is the perimeter of the pile, times L. Okay. And your L is the unknown value, that is 10.9 meters. Okay, so therefore at 10.9 meters, the capacity of the file is 360. The design capacity of the file is 360, having a factor of safety of 2. Okay, so ganyan lang kadali yung kasimple yung pag-solve for the length, the capacity of the files. Okay. Okay, do you have any questions for this problem? Okay. So, next problem natin is gagamit tayo ng alpha method and the beta method. Gamma method and the beta method. Okay. So, again, this problem is a past board exam. Okay. So, a driven pipe in a clay layer is driven as shown in the figure. So, the pipe has a diameter of 400 millimeters. Okay. So, meron tayong two layers. Yung sa taas is dry or moist. Hindi naman nakasabi kung dry or moist. So, yung water table kasi natin is located 4 meters below. Okay? Then, lahat yung ating pile is driven in a clay layer. So, clay to lahat. So, sa upper portion, ang cohesion value natin is 30 kPa. Then yung unit weight natin is 18 kilonewton per cubic meter. Then for within the water table, yung mga saturated clay natin, yung cohesion natin is nag-increase to 60 kilonewton per square meter or 60 kPa with a saturated unit weight of the clay soil, which is 20 kilonewton per cubic meter. Okay? And above is 4 meters, below is 6 meters. Yan. So, the question problem in the problem 1, okay, compute the skin resistance using alpha method. If your alpha is equals to 1.0 from the upper 4 meters and alpha is equals to 0.5 for the lower 6 meters. Okay. So, magkaiba yung alpha value since magkaiba yung cohesion nila, di ba? So, yan yung problem 1. Okay, for problem 2, compute the skin resistance using using gamma method if your gamma is 0.14 for the entire length of the pile. Okay, and compute the skin resistance using the beta method if the shaft to the soil friction, shaft to the soil angle is phase of r is equals to 30 degrees, and the top and the bottom of the clay layer is normally consolidated. Okay, so let us try yung problem 1. Okay, if you remember dun sa formula natin kanina, that is clap or yung alpha CP times L. Okay, so alpha C P times L. So so since we have two cohesion value, so we just need to find the summation of the alpha C P times L. So parang nangyari, ito yung soil yung pile natin. Okay. Ito yung pile length natin. And dito sa portion na to, iba yung value ng ng skin friction. Pero dito sa value na to, okay, medyo malaki na siya. So, magkaiba sila ng skin friction sa surface area, sa upper portion and sa lower portion. Okay. So therefore, the total skin resistance using the alpha method is summation of AC times P times L. Okay, yung alpha nung upper portion is 1.0. Okay, the cohesion of the upper portion is 30. Okay, and the perimeter is pi over 4. Pi times 0.4 or pi d. And the total length is 4 meters. Then dun sa isa naman, 0.5 yung alpha, whereas yung cohesion value is 60. Then the same perimeter, pi times b. Then the total length is 6. Therefore, your skin resistance using the alpha method is 376.99 kilonewtons. Okay. So basically straight forward equation, and ilalagay nyo lang yung data. Okay, next, the skin friction using the gamma method. Okay. So if you recall yung gamma method, formula for gamma method is P times L times FAB. Whereas yung FAB mo is gamma P sub B plus 2C. Okay, again, yung P sub B mo is the horizontal force per linear meter, and yung C is the average cohesion of the soil. Okay? So, paano ba yung pressure diagram dito? Okay, so, now, ang pressure diagram for the clay is simply how you solve for the pressure, yung pressure diagram, normal pressure diagram. So, from 0 to 4 meters, so meron kang 18 times 4. So, this is the total total stress. Okay? So, 18 times 4. Yan. Total effective stress. Which is equals to 72. Then, after that, yung from 72, mag-i-increase ka ng 20 minus 9.81. So, yan yung effective. Means ka-saturated siya. Okay? Times 6 meters. So, yung coordinate nito is 133.14. Yung coordinate nito is 72. So, magkaiba yun ng angle ha. Baka isipin nyo the same. So, there are different angle. So, yung coordinate nito, again, is 72. Yung coordinate nito is 133.14 kPa. But the difference is just simply yung 20 minus 9.81 times 6. Yung difference nito. Okay. So yan yung effective stress natin. So next is compute the average value of C. Okay. So the average value of C is magkaiba yung cohesion value. So yung nasa taas, gagawin nyo lang the cohesion value times the total length plus the cohesion value ng bottom part times the total length divided by the total length. Okay? So 30 times 4 plus 60 times 6 divided by 10. Yung 4 is the 4 meters, yung 6 is 6 meters, and 10 is the total length of the piles. Okay, therefore the answer is 48. So this 48 is the average value of your cohesion. Okay, next unknown is yung phi sub v. Okay, the phi sub v is the total okay, ang kalakay dito is phi sub b is the sum of the total horizontal force exerted in the piles. Bakit horizontal force? I think there's something wrong dun sa okay. I think mali ito. Dapat ito ay total vertical force. Mali yung Kaya pala siya may subscript na V. Okay. Again, this should be the sum of the total vertical force. Okay, dapat ito vertical force. Yan. Okay, so again, P sub B is the sum of the total vertical force exerted in the piles divided by the total length of the piles. Okay, bakit may error dito? Okay, anyway. So yun, again, yung P sub B is the total vertical force per linear meter of the pile. Okay. So, the formula is, syempre, yung area 1 plus area 2 divided by the total length of the piles. So, ganun lang yung gagawin natin. Okay, ang area 1 natin is 72 times 4 divided by 2. Okay, so that is 144. Then, yung area 2 natin is, this is a trapezoid and the area of trapezoid is B1 plus B2 times height over 2. So 72 plus 133.14 times 6 divided by 2. Therefore, your area 2 is 615.42. Okay, then your phi sub B is the average, is the total vertical force per linear meter L of the piles. So 144 plus 615.42 divided by 10, that is 75.942 kPa. Okay, then your FAV is given by gamma factor multiplied by phi sub B plus 2 times C. Okay, that is 0.14, 75.942. Ito yung vertical force per linear meter. 2 times the average cohesion, 2 times 48. Therefore, your FAV is 24.07. Okay. And next is your total skin resistance. So that is P times L times FAB. So P mo, perimeter, is Y times D. Your L is the total length of piles, that is 10. And your FAB is 24.07. Therefore, your total skin friction resistance is 302.47 kN. Okay, so ito yung answer mo dito. Again, phi sub B is the total vertical force per linear meter. Okay. Next problem is skin friction resistance using the beta method. Okay, the same formula, P times L times FAB, whereas your FAB now is 1 minus sine P sub R. Okay. Ang natin is 1 minus P sub R, tangent phi sub R. Okay. So, multiplied by sigma average. Okay. So, from 0 to 4 meters, ito yung pressure diagram natin, di ba? So, yung from 0 to 4 meters, so 0, 72. So, ang coordinate nito, alam natin ang coordinate nito. Coordinate nito 0, coordinate nito 72. Coordinate nito is 133.14. Okay, therefore, yung sigma average is just simply the average of yung from 0 to 4. So, average ng value na to and yung value na to. So, this is 0, this is 72. So, take the average, you have your 36 kPa. So, this 36 kPa is the average pressure at 0 to 4 meters. Then, from 4 to 10 meters, meron kang coordinate pressure na 72 and 133.14. So, just take the average, 72 times plus 133.14 divide 2. Therefore, the average from 4 meters to 10 meters is 102.57 kPa. Okay? Then, you have different values of FAB since magkaiba yung sigma average mo. Kasi ito yung total FAB mo. Okay, since yan yung total FAB, yung formula for FAB mo, magkaiba yung sigma average mo. Therefore, meron kang FAB sub 1. And ito yung FAB mo sa top. And ito yung FAB sub 2, yung FAB mo dun sa ilalim. Okay? So from 0 to 4 meters, your FAB is 1 minus sine 30 tangent 30 times 36. Therefore, that is 10.39 kPa. Then from 4 to 10 meters, that is 1 minus sine 30 tangent 30, 102.57. That is 29.61 kPa. And again, using the summation of P times L, FAB. So P times L, perimeter, pi times D, times L, which is 4 meters. Ito yung nasa upper portion. Multiplied by the FAB, that is 10.39. Yung isa naman sa ilalim, from 4 to 10 meters, that is pi times D, times the length L, times FAB, that is 29.61. Therefore, your total skin friction resistance is 275.48 kilonewtons. Okay, so do you have any questions for the skin friction resistance using alpha, beta, and gamma method? Okay, sige. And last problem is yung driven piles in a sand layer. Okay. So dito, again, ito ay from the Basabilia Foundation Engineering. Okay, a circular pile having a diameter of 0.3 meters is 12 meter long, as shown in the figure. This is your figure. Okay, which is embedded in a layer of dense compacted sand having the given properties. Okay. So compute the point bearing capacity of the pile or yung end bearing capacity or yung Q sub kip. Then the frictional capacity of the pile. And next is the allowable capacity of the piles assuming a factor safety of 3. Okay. So ito yung ating given. So meron tayong water table at 4 meters below. And meron din tayong ito yung the saturated unit weight is 20 kilonewton per cubic meter. The bearing factor N sub Q is 80 kPa. 80, but may kPa, 80. Your K value is 1.2. Your mu is 0.4. Your Fs is 3. Okay. Sige. Let's try. Okay. So the diameter of the pile is 0.3. So before we go for the analysis, we need to determine muna yung D sub C, yung length D sub C. Ito yun. Yung critical depth D sub C. So yung critical depth D sub C is for loose, that is 10 times size of the pile, and for dense, that is 20 times the size of the pile. Okay. So ano ba yung problem natin? Ang problem natin, ang sabi niya dito, dense compacted sand. Okay? So therefore, ang critical depth natin is 20 times the size of the pile. So ang size of the pile natin is 0.3 or the depth of the pile is 0.3. Therefore, the total depth is 20 times 0.3, that is 6 meters below. Yan. So 6 meters below yung ating critical depth. Yan. Then, so gagawin mo, ito. Yan. And ito, may 2 meters ka pang natira dun sa may saturated part. Then 4 meters yung nasa upper portion. 6, ito dapat 6. Ayan. So yung P sub D1, okay, is basically 18 times 4 lang, di ba? 18 times 4, 72. So value nito is 72. Yan. Pero yung point ng this one from dito, linearly increasing to ha guys. So from dito, papunta dito sa point na to, linearly increasing siya, but effective stress. Kailangan mo ng effective stress. So basically, i-add mo lang yung nasa taas. So 72 plus, ano ba yung nandoon? That is 20 minus 9.81. Effective ha, times 2. Tama? So that is why meron kang 92.38. So itong coordinate na ito is 92.38. Ayan. So this should be KPA. This should be KPA. Okay? So ganyan. So 72, 92.38. Then after from 92.438, uniform pressure na yan hanggang baba. Okay? So 92.38 dito. Ayan. So ganyan yung pag-solve natin. Okay. So meron na tayong pressure diagram. So ito na yung gagamitin na working pressure diagram natin. Okay. So ang tanong is the point bearing capacity. Okay. So point bearing capacity, the formula, ano yung formula natin? The formula is Q-tip, that is perimeter, effective pressure at the bottom. Okay. NQ, the soil bearing capacity, the soil bearing factor NQ, and A tip, that is the area of the tip. So PE and Q tip. Okay. So, ang notation niya lang dito is P sub P. So PE is the effective pressure at the bottom. So therefore, that is 92.38 kPa. Yan yung nasa ilalim mo. Okay? Multiplied by the bearing factor NQ. Ang bearing factor NQ mo is 80. And the area at the tip, ano ba yung area mo? Ang area sa ilalim mo is a circle. Therefore, that is pi d squared over 4. That is pi d squared over 4. Okay? Therefore, your point bearing capacity or the Q-tip is 522.4 kilonewtons. Okay? So, ganyan lang yung pag-solve dito. Okay, next, the frictional capacity. Okay, for the frictional capacity, that is P times the area of the pressure diagram, K times mu, or ang notation namin dyan is PAC mu. Okay? So, PAC mu. Okay? So, P is the perimeter, A is the area of the pressure diagram, okay? K is yung factor K, and mu is yung coefficient ng friction. Okay. So ano ba yung mga given natin? Yung K natin is 1.2, mu natin is 0.4. Okay, yung P natin is perimeter, that is pi times d. So unknown natin is the area of the pressure diagram. Yun na lang yung kailangan natin i-solve for frictional capacity. Okay, so for the area of the pressure diagram, let's simply solve this one. Okay? So sa tingin nyo ba, the question is, kunyari, ito-drawing natin yung pressure diagram. Ito yung problem eh. Ito yung kalimitang problem na na-encounter dito. Yan. Then, this one. So, for example, ikaw muna yung gumawa. Okay. So, for example, ikaw lang muna yung gumawa. Ganyan yung ginawa mo. So, this is 4 meters. This is 2 meters. This is yung, ano ba to? Ilang meters to? 6 meters. Ayan. Okay. Ayan. So, ganyan yung una mong gawa. So, ang gawa mo, ito, alam mo to ng, this is 72 kPa. This is 92.38 kPa. Ito ay 92.38. Okay. So, ang una mong gagawin, ang kalimitang mistake dito, ang gagawin nila, hahatiin nila to sa dalawa kasi nakakita sila ng triangle and square. Gagawin nila, so the area of the pressure diagram is simply the area of S1, the area nito, plus area nito. So, area ng triangle. So, 92.38 na gagawin nila, 92.38, okay, 92.38 times 6 over 2. Okay, plus 92.38 times 6. Ganyan yung gagawin ng karamihan. So, hindi nila, this is wrong. Bakit? Bakit mali yan? Kasi ang ginawa nila, kinonsider nila na one triangle ito. Okay? Kinonsider nila na isang malaking triangle ito. Which is hindi. Bakit? Kasi magkaiba sila ng angle. Magkaiba sila ng angle ng pressure diagram. Okay? So kung gusto mong i-check kung magkaiba nga ba talaga sila ng triangle is Ang gagawin mo lang, kunin mo yung angle nito and kunin mo rin yung angle nito. Okay? Yung alpha 1, let's say, sige, wag alpha kasi may alpha method eh. So, alpha, beta, gamma. Okay. Ito, kunwari, angle 1, ito, angle 2. Yan. So, kailangan mong i-determine kung same angle ba sila. Kasi kung same angle sila, yes, pwede mong gawin yung ganon. Pero kung magkaibang angle sila, kailangan mo silang i-consider ng hiwalay. Okay? So, yan yung common mistake. So, ang tip ko, kailan malalaman kung same angle sila o hindi, is number 1, ito. So, pwede mong gawin, kunin mo to. So, kunin mo yung angle. Number 2 is the most easiest and mas straightforward is kapag magkaiba sila ng pinanggalingan ng nung linear increase yung yung unit weight of the soil. Okay, kasi itong nasa taas, ang unit weight nito is 18. Pero itong nasa baba is 20 minus 9.81, yung effective unit weight. So 20 minus 9.81, that is 12, or that is 11.19. 11.19. Yung isa, 18 yung ginamit. So, ibig sabihin, magkaiba sila ng total, ng effective unit weight. So, therefore, magkaiba sila ng angle of inclination. Okay? So, pwede mong gawin is find the area of this one plus area of this square, or plus area of this triangle plus area nito. Or pwede mong gawin area of the triangle above, then area of trapezoid plus area of rectangle, which is ito yung ginawa nung author ng book. So, ang ginawa niya, area of the triangle, 72 times 4 over 2, plus the area of the trapezoid, which is 72 plus 92.38 divided by 2, plus the total length 2, then the area of the bottom part, yung uniform pressure, that is 92.38 times 6. Okay, therefore, the total area of the pressure diagram, vertical pressure diagram, is 864.66 kPa. Okay? Then, since meron ka na yan, you can now directly solve for the frictional capacity. Therefore, that is pi d perimeter times area times K times mu, that is 391.16 kilonewtons. Okay? So, next natin is the allowable capacity. So, since meron ka ng frictional capacity, the skin friction resistance, then meron ka na ring end-tip, or yung tip of the file na end-bearing capacity. So just simply add them, divide by a factor of safety. Therefore, your designing capacity, or the allowable capacity, is equals to 304.52 kilonewtons. Okay, so that is how you solve for the capacity of 3-bed piles in assembly here. Okay, so do you have any questions regarding the topic? Okay, so B, maging maingat lang kayo dun sa finding the pressure diagram, mga ganito, or yung mga formulas. Pero yung the rest of this topic is very very easy lang. So kayang-kaya niyo tong i-solve. Okay? So kung wala kayong problem, so maybe that is all for our discussion. Okay? And thank you guys for listening. Okay, thank you.